Hi everybody. In this video we're going to be doing IXL 8th grade AA3 solve a system of equations by graphing word problems. Okay, so let's get to it. Two groups of workers are painting a bridge in the bay. The first group is responsible for painting the north side of the bridge, and the second group is responsible for painting the south side of the bridge. The first group has already painted 3 kilometers of the bridge and is painting 2 additional kilometers per day. Okay, so I'm going to use X and Y here instead of D for days or T for the total amount painted, just to make it like, just because very often when we're graphing things, here's my marker, very often when we're graphing things we just use the variables X and Y to represent the independent and dependent variables. So if X, let me underline this sentence here. The first group has already painted 3 kilometers of the bridge and is painting 2 additional kilometers per day. Okay, so if Y represents the total amount that they have painted, then Y would be equal to, let's see, they already painted 3, and then they're painting an additional 2 kilometers every day. So plus 2 times however many days passed. Instead of D here, I'm just going to put X to represent the number of days that pass. Okay, and now what about the second sentence over here? The second group has already painted 5 kilometers of the bridge and is painting 1 additional kilometer per day. Okay, so for them, if Y represents the total number of kilometers painted, then that would be equal to the 5 that they already had done, plus 1 times however many days passed. And remember, we're using X here to represent the number of days. Okay, so that would be the equation describing this sentence, which represents this sentence over here. Now we could solve, if we want to know when the two groups have painted the same amount of the bridge, we could do it like a couple of videos ago, where we just do 3 plus 2x equals 5 plus 1x, and then we solve for x here, and then we could plug x back into one of these equations to solve for y. But we're going to do it a different way in this video. We're going to just graph these equations and see where they intersect. Okay, so remember, in order for me to graph them, let's see, so for this one, the y-intercept would be 0, 3. So over here, I'm just going to put a dot on 0, 3. And then the rise and the run, this is like 2 over 1. Wrong color there. This is like 2 over 1. So that means if I want to find another spot on the graph, then starting from my y-intercept here, I could go over 1 and then up 2, and then that would be another point on the line. Okay, now remember, every single, well, you know what, I'll talk about that a little later. Let's just graph this one over here. So the y-intercept here is going to be 0, 5. What was it? What am I doing over here? So 0, 5 for this one. Okay, and the rise and the run here are, this is like 1 over 1. So we go over 1 and then up 1. Okay, and actually I sort of went the long way here by writing these equations out. Really, it's pretty easy to graph these lines just by reading the sentences. So for example, the first group has already painted 3 kilometers of the bridge and is painting 2 additional kilometers per day. Well, yeah, so over here, look, we just put a dot on 3, so they already painted 3 kilometers of the bridge, and then every day that goes by, they paint another 2 kilometers, right? Another day goes by, they paint another 2 kilometers, okay? So you could have graphed this line even without writing this equation first, honestly. And the same thing for the second sentence over here. The second group has already painted 5 kilometers of the bridge and is painting 1 additional kilometer per day. So just by using that information, you can immediately put a dot on 0, 5 over here, because they started out 5 kilometers had already been painted. So just put a dot over here on 5, and then each day that goes by, they paint an additional 1 kilometer. So another day goes by, another kilometer, another day, another kilometer, another day, another kilometer, and so on. So really, you could have done it that way and just put the lines down here on the graph immediately, even without writing these equations over here. But keep in mind that every single point on here is a solution to these equations, right? So everything on this line is a solution to this equation, and everything on this line is a solution to this equation. So for example, let me take this line over here. This point over here is, let's see, 4 days and 9 kilometers. Okay, the distance is measured in kilometers. If I plug in 4 for the days and 9 for the kilometers, okay, 1 times 4 is 4. So you get 9 equals 5 plus 4. 5 plus 4 is 9. So you get 9 equals 9, right? So this is a solution to this equation over here. And in fact, every single point on this line is a solution to this equation. You could plug in more points if you want. If you plug in 5 for the days and 10 for the kilometers here, you would see that that also works. Okay, and you can say something similar about the other equation. Every single point on this line is a solution to this equation over here. So for example, let's just pick this point right over here, which is, that would be 1 there and 5 for the kilometer. So 1 for x and 5 for y. Okay, 2 times 1 is 2. You can see that this also works, right? 5 equals 5. Okay, so every single point on this line is a solution to this equation. Now, what we're trying to figure out, basically, for this exercise is what solution is common to both of them. Well, if every one of these dots, if really everything on this line is a solution to the second equation, and everything on this line is a solution to this first equation, then you can see where they intersect, that's a solution to both of the equations. It's a solution to this one, and it's also a solution to the other one, which I erased, okay? So the solution here is 2, 7, okay? So if 2 days go by, then both of those teams will have painted 7 kilometers of the bridge. All right, so the intersection of the two lines is the solution that solves both equations. And really all we want to know here is how many kilometers did they, so after 2 days go by, then both of them painted 7 kilometers, and that's what we're going to type in here. All right, so let me do this one quicker. I really wanted to just go through that so you understand the logic of everything, but this one I can do faster. So the Student Council at Springfield High School is making t-shirts to sell for a fundraiser at a price of $15 a piece. The costs, meanwhile, are $5 per shirt, plus a setup fee of $60. Selling a certain number of shirts will allow the Student Council to cover their costs. How many shirts must be sold? So let's see. Let's do the revenue first, which is the money that they bring in by selling these shirts. So they're selling these t-shirts for $15 a piece, $15 for each t-shirt. If they sell 0 shirts, then they're going to make $0. So we can put that on the line immediately. And then for every shirt that they sell, they're going to make $15. So after they sell 1 shirt, they'll make $15, except I can't really put that on the graph here. I can go from 1 this is 10 and then this is 20. I can't really do 15 here. But what I can do is I can say, well, if they're selling the shirts for $15 per shirt, then if they sold 2 shirts, that would be $30, right? So I can put this one on the graph, and then there's my line. Okay, if they sell 4 shirts, then they'll make $60. If they sell 6 shirts, then they'll make $90, and so forth. Okay, so that's how much money that they're bringing in. How much money does it cost them to actually make these shirts before they sell? They have to manufacture these shirts before they sell them. Well, it cost them an initial setup fee of $60. So for the cost here, what it cost them to make the shirts, even if they make 0 shirts, it costs them $60 just for the setup fee. So we can put 0.60 on the graph here. And then it costs $5 for each additional shirt that they make. So they have to pay $60 right away, just I guess to pay the manufacturer who's making these shirts for them to then sell to other people. And then for each additional shirt made by the manufacturer, they have to pay $5. Well, this would actually be 10 here. I can see that it's going up by tens here, 60, 70, 80. So I can't do it here, but what I can do is I can say, if it's costing them $5 to make each shirt, then 2 shirts would cost $10. So I can go 2 spaces over here, and then up here, okay, that would be $10 for 10 additional dollars here from where I started to make these 2 additional shirts over here. So that makes sense. All right, so the setup fee was $60 and then $5 per shirt, or $10 for every 2 shirts. And then every single thing on here tells us how much it costs them to make a certain number of shirts. So if they sell 4 shirts, if they were to get 4 shirts manufactured, then it would cost them $80. So you can see here that the amount that it costs them to make these shirts, for a little while here, it costs them more money to make the shirt than is the money that they're bringing in by selling it. So for example, if they were to manufacture 2 shirts and then sell those 2 shirts, well, it cost them $70 to make those shirts. That's the blue line. And then if they sell those 2 shirts for, remember, $15 each, then they're only making $30 back. So they would actually be losing money here. Everywhere where you see this blue line is above the orange line, they would be losing money. But then a little bit later, where the orange line is actually higher than the blue line. So for example, what can we say over here? Well, not really. Well, it's going too high here. But anyway, if the orange line is higher than the blue line, then that means that the money that they're bringing in from selling the shirts is greater than the money that it cost them to make the shirts. So they are making a profit at a certain point. Now, we might want to ask ourselves, over here they're losing money, over here they're gaining money. Where do they break even? When is the amount of money that they spend to manufacture the shirts exactly equal to the amount of money that they bring in when they sell those shirts? And that's where these 2 lines intersect, which is right over here. And we can see that if they manufacture and then sell exactly 6 shirts, then it cost them $90 to manufacture those shirts, and it also cost them $90 to sell those shirts. Okay, so they would break even there. And then so the answer to this question is just 6. It would cost them, be careful, it's not asking us how much money they would make. It's asking us how many shirts, what's the break, where would they break even? That's if they manufacture and sell 6 shirts, okay? So I'm going to end the video there. The rest of these problems are pretty much the same. I hope that was helpful, and have a great day.